So we have the opportunity to be in a soil pit here in this Macclesfield area, which is currently under grazing management, but in the past has been under the influence of irrigation. So there'll be some interesting characteristics to discover here today and work through and how it might relate to your property and what some of the underlying constraints or opportunities there are sitting in your soil profile. Like with any soil pit, when we want to have the opportunity to understand it, we want to work out initially is how many layers are existing in the soil. And as we work down through the profile, we can see we've got like a 0 to 10 centimetre layer, which is really typical. Sort of generally across the Fleurieu region, you'll have this 0 to 10 centimetre layer. Then underneath that, we're sort of looking at this 10 to 30 centimetre layer, which is still got similar coloration and texture to the layer above it, but just doesn't have the same rich darkness of it, which is characterized by that 0 to 10 centimetre layer. Still good root material present, but we do see a little bit more rock fragment coming into that layer. So as we go through, we want to find out what sort of rock fragments are they? Are they quartz? Are they schist? That tells us a little bit around how this soil was essentially formed and what other constraints we might be looking for down the track. As we keep on going down, so around this 30 centimetre layer, we can see there's a bit of a visual difference here. One of the soil colour, getting a real brown, earthy looking colour, as well as then this lighter coloured cap on top of this layer. What we've actually picked up here, there is a change in clay content. So overall, we've got a texture contrast soil, so a lighter textured soil sitting over a heavier textured soil. Heavier textured being higher in clay content. So we've seen that increase, and then we want to find out more around what's going on down. As we creep down into this sort of 50 to 70 centimetre range, we've then got a increase in some rock material coming in. There's still evidence of root material down through here, which is excellent. And then below around 700-800 mils, we've then got a real soft rock that's here. So you can still see that it's got its laying of how the rock was in situ, but it's actually really quite soft. So it's a weathered rock, so weathered siltstone in this case. So a number of the soils in the hills region, especially on the Fleurieu Peninsula, have this element of weathering rock underneath them. And weathering is that process of breaking a rock bed down into soil. So we've got to be thinking like some of this soil here has actually been formed in situ from the rock below. We'll also have influences from soil moving down slope. We're sort of on a mid slope here as well. You have soil moving in and down, as well as then weathering in situ. So over time, these subsoils will continue to weather, and that rock that is now a softened rock with still the same rock-like characteristics, and in time that'll have more soil-like characteristics with that further weathering processes. As we go back through these soils, we've got like the macro colour of the soil. So we've got this greyer colour sitting over the reddy brown. When we've got that colour change, we then want to be looking a bit deeper into saying, are there any subtle changes in colour as well? And we can see in this upper part of the profile, sort of in the lower half of this top soil, we're starting to get a few little flecks of brown in amongst the grey. And then as we go down into the browny red soil, we've then got these real mottly red along with the browns. So we've got this colour change that is occurring. We've got good root material moving down through, but we can see there is a bit of a mottled nature in this soil profile. As soon as we see that mottling, we'll know it's going through periods of significant wetting or holding a lot of moisture. So what that does is reduces the oxygen content of the soil and changes how that soil is behaving, especially down in these clay layers where we've got a bit of structure here that is sort of relatively well defined. When this wets up, it swells and closes all the cracks and then cuts off that pathway of oxygen to get down into the soil. Yet all of those biological processes are still going, so there's microbes in there breaking down roots, using oxygen in there, and that'll start leading to some of those grey colorations in the soil. But overall, with the general reddy brown colour, you'd say it's relatively well oxygenated as a main point, but we are getting periods of it being a bit more anaerobic. This is quite typical for higher rainfall areas, especially in the Adelaide Hills. We've got this weathering occurring and this stratification occurring in the soil, where we've got the more loamy soil sitting over the clay soil. So when you think about the rainfall, you think about the water moving through a soil as path of least resistance. So the water will more rapidly move through this upper part of the profile. Once that's filling up, it'll be then moving down into this clay soil. As that swells and closes up, it gives us less room to push water down into there. And this is critical, that the rate at which that water can move through the topsoil is slower than in that clay. So what will happen is that water will start moving laterally across the landscape, and especially because we are on a slope, it'll move down slope, taking with it some of the nutrition over time. So that's where we can get these minor little bleach layers, so a white layer sitting at the top of the clay, which can vary in thickness throughout the Fleurieu Peninsula. But also just need to be aware of where that water is moving to and why we are hitting these periods where the subsoil is quite saturated. Quite often that saturation is happening right over the coldest part of the season as well, over that winter period. So that's where, if we can get some root material down into these soils before that soil closes up, it's really beneficial. So they can keep some of those pathways open, where if this was running solely on an annual cropping or pasture-based system, the risk is we don't get that root material down into to explore the subsoil before it closes up. And then it's not until spring when we can start really actively utilising that subsoil. So now we've identified the different layers in the profile, another test we can be looking at in the field is to look at the field pH test. So the field pH is just a simple solution you can get from the hardware store. So it comes with a liquid and a powder which you treat to the soil. I grab out a little subsample out of each of the layers. One that helps me identify, have I picked up the different soil colours and representative soil layers, but also it helps me link back to keeping it closed in a bit of a zone here where we know what area we have sampled. So I went down here and we did the 0 to 5, 5 to 10, then down in the 10 to 30 centimetre range, around that top of the, so around that 30 to 35 centimetre layer, and then 35 to around the 55, and then into 70 centimetre and below. What we can see here is sort of this pattern as we go down of being slightly neutral to slightly alkaline on the surface, so in that 0 to 5 centimetres, and then we see it around that around the 6 pH, 5.5 to 6 underneath that, so in that 5 to 10 centimetre. Why is that? Once we spoke to the landholder, found out that the property had been limed about 18 months ago, which is giving us an indication of how that lime is tracking down through the profile. So after sort of 18 months, 2 years, we can see that lime has moved only about 5 centimetres. And that's really something to keep in mind when you are liming. It doesn't necessarily move through the profile. Sometimes we have to think about, do we need to incorporate? As we go down, so that second layer, true layer in the soil is sitting around that 6.5, 7 pH mark. And then below that, once we hit the clay, we're seeing this pH increase. So that's sitting at around the 8 pH at the top of the clay, then increasing to 8.5, 9 pH down through the profile. This was really interesting. It wasn't fully expected. Typically in this higher rainfall hills region, you'd be more expecting it to be relatively acidic or neutral to acidic underneath the surface here. But we've been surprised by this more alkaline layering underneath. Upon further investigation, found out that this property had actually been under the influence of irrigation for a number of years, which had been sourcing water from a bore. So potentially, without doing more testing, this increase in pH here is potentially attributed to carrying a higher loading of salts down in this subsoil, which from irrigation water perspective, that's where we need to be making sure that we know what we're applying when we are irrigating. So we can have the salts in water as well as the neutralizer or the alkalinity. So you can have carbonates and sodium in water, which is going to influence the soil. So you want to be thinking about as the water is, so as you see your water test, the soil will become with enough water that goes on. So that's critical to understand. When we do have salts in our profile, we want to be thinking about how we then move them, which is then looking to leach them out through the profile. Due to having such a good clay soil underneath here, moving or leaching that through can be a little bit more difficult compared to a sandy soil which has higher hydraulic conductivity or capacity to move water through it. By identifying the fact that we do have a more alkaline pH, that's part of the puzzle to solve, to work out what might be constraining this subsoil. What's really interesting, we do have still good root development down into sort of that 80 centimetre depth, which is really interesting. So potentially in the summer fodder that's been planted, we might have some more salt tolerant plants such as lucerne, which might be able to handle that layer. Or when we look at that, is there some other factor that's driving that pH? And it may not be severe enough to constrain certain plant production, but be enough to drive that pH change. As we found in this profile, there's differing layers within this soil that have differing stone content or rock content in each of the layers. Obviously, and it is quite a characteristic of a number of the hill soils to have essentially a basement rock or a bedrock here that is weathering, and below that, as you keep digging down, the rock will start to get harder and harder, and that tells us how much of that rock layer is actually weathering here in situ. But within this profile, there's rocks sitting through it. So if you ever dig up your own soil and find there are rock fragments through the soil profile, we want to be thinking about how much area are they taking up. And the trick is, when you are sending a soil off to the lab, if there's a whole lot of rock in that bag, you want to be thinking about how much area is that taking up. Because if you've got a 10% rock fragment in a layer, or is it 30%, when you're getting those soil results back from the laboratory, a lot of that data is presented in, say, milligrams per kilogram. But you've got to be thinking about when you shipped off that kilogram of soil to the lab, maybe 30% of that might have been rock fragments. So we've got to be taking that into account when we're doing our full nutrient budget. In situ here as well, is we've got to be thinking about what's happening here when we do have rock fragments in through the soil profile. One, in this sort of environment, it does really help drainage. So some of those rock fragments do sit in between the soil particles and allow for water to move through. So this interface between this loamier topsoil sitting over the clay, that can help bridge that gap of water actually infiltrating into that subsoil. What it then also does affect is how much water this soil can hold. So the more rock fragment there is in the soil, essentially the less water the soil's got capacity to store, because it's taking up vital space where we'd otherwise be storing water in the soil pores. So when you have some rock fragments in there, suddenly when you've got a rock fragment sitting next to fine soil, you've then got that space being taken up. So it's just something, when you are trying to do your own water budgets or nutrient budgets, you want to be really taking into account the volume of rock material that is in each layer, to make sure that you're estimating the right irrigation requirements if you irrigate, or even water storage potential if you're relying on a dry land influencing production system. So if you'd like any more information on soil management, please contact Landscapes, Hills and Fleurieu.